So we finished up yesterday with wrapping up with graphing and factoring it out. Today, we are going to talk about what was different between the parts with the part A and B and C and D. What was the difference between those two? So look at your A and B from the previous ones versus your C and D. What are some differences you notice between the first two and the C and the D? What'd you factor out on A and B? Factor out an x in both those two cases. Do we factor out any variables here? Do we factor out any variables here? Okay. So A and B we're able to factor out a graph, factor out an x. And what was different about our graphs in each of those? Let's to look. So what did A and B do that B and C did not on the graph? Hint, look at that blue circle. So A and B cross the origin, right? C and D did not. So A and B were able to factor out an x, and the graph went through 0, 0. So all polynomials that have a monomial GCF that contains a variable, basically, can you factor out something that has, is your GCF something like 3x, x, 7, x, something that contains a variable? What is going to be true every time on the graph? It will always do what? It will always go through where? The origin. So on this next one, Tony says that he was able to remove the GCF of x, and he's left with the expression of x minus 2x plus 2, and it cannot be factored, so therefore, this is where we stop. Eva said, well, we were taught that quadratic formula a while back, and that got me to where I could get roots. And if I know what the root is, then I can find the factor. So therefore, it can go further. Who is right? If we're only looking at the real numbers, who is right? Would Tony or Eva be right? Tony. If we're only looking at the real number system, then Tony is right. But if you're also wanting to consider the complex, then Eva's right. So if you want to consider imaginary or irrational numbers, then we can go further. But if you're not looking at going that route, then we'll stop at this factor. So let's go ahead and I want to show you how Eva got hers because it's going to be good to go back over how you use the quadratic formula. And so we started off with x cubed minus 2x squared plus 2. Is that correct? Or plus 2x? Is that correct where we started? Okay. So they both realize they can factor out an x. Gives you x squared minus 2x plus 2. And then we're going to take this section and go further with it. So remember, when we are starting the quadratic formula, we always went to our A, B, C first. So what's A? It's all going to come from inside this parenthesis. What would A be? It's the x squared. It's the number in front of it. So 1. B is, and C is. And so from that information, we're going to go into the discriminant. Which is b squared minus 4ac. So negative 2 squared minus 4 times 1 times 2. So 4 minus 8, which is negative 4. That's your discriminant. We're going to take that information and go to the quadratic formula. X equals negative b plus or minus the square root of our discriminant all divided by 2a. So negative b is opposite of b, so 2 plus or minus. What is the square root of negative 4? Not what is 4 squared. What is the square root of it? Two I. And then 2 times a. So 2 times 1. So 2 plus or minus 2i over 2. And now let's simplify it down. This 2, we'll have to divide it into both of these two pieces for us to simplify it down. 2 divided by 2 is 2i divided by 2 is 1i or 1 or I. So these are the solutions, this one and x equals 0. If it wants us to take and factor it, then we need to take our solutions and go back to what it would be. Or this could also be called the zeros. If I wanted the factors, x is one of my factors, but I need to find the other two. And so you say x is equal to 1 plus I, and x is equal to 1 minus I. And that means that if I get everything on the same side, x minus 1 minus I is equal to 0. And so x minus 1 plus I is equal to 0. So that gives us our parentheses. And so that means our factors are x times x minus 1 minus I and x minus 1 plus I. So we want to see, on this next little bit, we're going to be looking to see, are they imaginary or complex solutions? Or are they real solutions? So if I take these factors, or these polynomials, which of these are going to have only real factors? Which of them are going to have imaginary? Which one would you like me to work? This one? Okay. So how do I find out what goes up here? It'd be the product of these two. So that's 5x squared. And the 2x goes down here. So what can multiply to give me 5x squared? What's two things that can multiply to give me 5x squared? $5x and 1. Is there any other option? What about negative 5 and x and negative 1? Would either of those combine to give me 2x? No, so it's imaginary factors. I'm going to give you some hints for x squared plus 4. This is the same thing as x squared plus 0x plus 4. And the other hint is that negative x squared plus x plus 12. When I factor out the negative, it becomes negative in front. X squared minus x minus 12. This may be easier for you to do. The reason I give you this choice. And y'all are going to come up with which of these have imaginary and which of these have real factors. There are fewer with real factors. Okay. Because when we did our x on this one, we end up with x squared here, or excuse me, negative 5x squared and 4x, so 5x and negative x. What's the next one? What's another one that can get factored? Well, can this one? Can x squared plus 4? So that's 4x squared. We want to get a zero product. Can I factor that? So what two things can multiply to give me 4x squared? Positive 4x. 1 and 4, and or either is going to have a sum of 0x. So it's not possible. So x squared plus 4 is imaginary factors. What about the next one? Same idea, but this time we have a negative 4x squared and a 0x. So negative 2x and positive 2x. So is that factorable? Well, this next one, I recommend factoring out that negative like we set up here. And so we have x squared times negative 12 is a negative 12x squared. And then the negative x goes down here. But two things multiply to give me negative 12 that are 1 apart. That would multiply to give me 12. We need one of them to be negative, which is going to be negative. Negative 4, positive 3. On the next one, we have x squared is 4x minus 1. What goes in the top part of my x? What two things multiply together to give me 1 that will add to give me 4? So 1x squared is either made up of 1x times 1x or negative 1x times negative 1x. Or are those going to combine to give me 4x? Remember we factored it out up here? Oh wait, that's supposed to be a 12 right there. No, that's not the right one. I'm doing this one right here. X squared plus 4x minus 1. So that doesn't work. So if I have the negative x squared plus 6x minus 25, what should I take out first? Is there a negative in front? So we factor out that negative. And then we're going to use our x's. So 25x squared and negative 6x. What can multiply to give me negative 20, or give me a positive 25x squared that would add to give me a negative 6x? Well, our choices are 5x and 5x, or 1 and 25. Are either of those going to work? So that means we're not factorable. And so negative x squared plus 6x minus 25, or you could have written it as negative x squared plus, excuse me, not plus, minus 6x plus 25. My next goal for y'all is for y'all to factor this list. So get it to the point where it looks like this. Okay? If you're done with that, go ahead and use the quadratic formula to help you come up with the solutions, not the factors for the imaginary roots. So you're just getting to this stage. Okay? And not taking it all the way to the roots, but just stopping there, and that is your homework if you do not finish it up in class.